Okay, here's something interesting. Um, uh, the interesting part here is that I have something that I define as shape, and at the same time I know that shape in itself doesn't help that much. You know, instead of designing individual circles and rectangles and triangles, I could have one uniform class named shape and include inside shape some sort of like an integer variable, maybe like the enumeration type, which would basically say this is the type of shape. And the type of shape could be circle, or rectangle, or triangle, or polygon, and things like that, or a point, a single point. And in that case, if I write code for class shape, I will constantly, all the time, have to say, if type is this, do this thing. If type is, other type, do other thing, and use other, different formulas, right? So, for example, I may need to use formulas to calculate area of my shape. I may need to use formulas to calculate perimeter. If this is some sort of a manufacturing aspect, I may also have to calculate a weight, just physical weight of an object, of a physical object. So I may have to do a lot of different things with my shapes. And if I design a one single class with the type variable in it, so that each shape that gets created remembers the type in an integer, and each real type is unique integer value, like circle is 1, rectangle is 2, triangle is 3, a star is 4, and so forth, right? Then the code inside the shape class will look like a nightmare, because I can't do anything at all without on each other line checking if it's this kind. So that's why, to make things design much in a much nicer way, the decision is that let's have a circle and rectangle and triangle and other shapes a separate class, and let them have, let all of these classes do the same thing. But in their own unique version of it. So let's start with that aspect. So now I can say, all right, so here's my package. Let's create a new class named the same package, named circle. Okay, so here's the circle, right? Create that class. Okay. Then let's go in and also instantly create a new class named rectangle. Okay, so new rectangle, finish. All right, so we have a couple of classes. That's a good idea. The next thing is that obviously all of these need a constructor. For example, a rectangle needs to be publicly constructible, and takes a couple of, I don't know, we could use double. Let's use double. Or we could use float. We never use float. But actually, graphic libraries love float, because you don't need that much precision on the screen when everything is projected on the screen. If it's a little fraction that describes position or color or something like that is just a little off, no one's going to notice that. It's a great approximation. So floating type of floating point numbers are extremely popular with graphic libraries. So let's use floating point numbers today for this demonstration. So okay, so this can be height maybe, right? And then another float data type for the width. Okay, so that's great. then of course the body of my constructor is going to say is going to need to store those two variables. So clearly I need to add them to my class's data attributes, right? So data attributes that a rectangle needs would be height and also the width. So these two, so I can take my this height equals height and this width equals width. So these are very, very standard type of constructors that basically say, all right, give me some parameters and immediately store these parameters inside the object. So to make everything look nice, private, right? Private height and private width would be the types of data attributes we need. Then these are my constructors. So these are my constructors. And finally, let's add some operations. Right? So operations could be float, or actually public, right? Public method returning a float, get perimeter, right? Get perimeter, just, you know, return what? Return 2 times height plus width. Okay, so very simple, right? So that would give me the perimeter of my drawing primitive, as well as public float get area, right? Calculate the area of a rectangle in this case. So here we get to, you know, specific formulas. So we return the value, which is basically height times width, right? And it's the user who knows what the actual units of measurements of these heights and widths are, right? Because eventually, if this is a primitive submitted to some sort of like graphical rendering server, such as, you know, your graphics card, what's going to happen is that all of these parameters, coordinates, and everything are going to be translated into a set of device coordinates, or normalized coordinates, which actually range from -1 to 1. That's the outcome of what the device will be using eventually. But as we, on the user side of things, we'd like to use our own units of measurement. So again, it could be inches, it could be millimeters, it could be miles, or whatever we like to use. So anyway, this should be essentially a more or less complete version of a rectangle to begin with, so we can do some manipulations with this particular primitive, right? So let me know if you have any questions. If not, I'll move on and do similar work for a circle, right? So in my circle, again, same basic ideas, data attributes. Now I prefer to keep the data attributes on top of my classes, because then if I start coding my constructors, I immediately see what data attributes I need my constructors to use to make sure I put my classes in good shape, right? In good state. So we'll say private float radius for the circle, and then of course constructors. So constructors will be a circle, which takes the float radius. Okay, and again, this one is even simpler. So basically, this radius equals radius that the user passed to us, right? So recall that when the constructor, typically the first interaction with our object we can possibly get to as early as possible would be inside of our constructor. So the memories are already allocated for a circle when this constructor begins to execute its code. However, to refer to the area of, to refer to the to data inside my object, I need to specify this in case if I also want to use the same variable name locally. In my case, I say, let's this constructor to take radius as a local parameter. So, and I want to use the same name for a local parameter. Why do I have to invent a brand new name for a local parameter if I can say this radius refers to the radius inside the object? And the radius without any kind of qualification is simply the parameter that the constructor gets from the user who is trying to say new circle and specifies the number of units to create it with. So anyway, just a quick review of what this is. Then, of course, the operations. Let's try the same operations to be supported. Oops. To be supported here. So first we said let's just say, I don't know, public float get perimeter, right? So just an operation that we want to support. So what do I return? Anyone? Circle, perimeter of the circle. 2 pi r. R square would be the area.
Okay, yeah.
The perimeter would be just
1 pi d.
yeah, 2 pi r, right?
Yeah.
So 2 times math dot pi actually is very convenient. Math pi provides the value of pi conveniently, and that is multiplied by the radius, right? So that should be, I don't know, a possible loss of precision. Oh, this is an interesting one. It says possible loss of precision because apparently math pi is defined as double, but I'm using floats all around. So how about I cast it to float, right? Float. That removes the problem here because I'm just saying, okay, drop that precision. Don't worry about this precision loss. I intentionally want to use floating point numbers. The next thing will be public float get area, and so here Cameron was absolutely right saying that we return basically what do we return for the circle area? Pi radius square, right? So math dot pi times radius, and square is like times 2 times radius, right? So if we multiply 2 times, that should do. And again, it's sort of like unhappy the detecting that this is the double. By default, everything is promoted to double in case if there are smaller data types involved in this computation, which in my case, but I would like to control it on my own and say, hey, let's just bring you down to float. Like, you know, come down, don't worry about it. We'll use everything as a float. Don't worry about the precision loss. It's okay. We'd like to just use a single precision, a floating point value. All right, so that should do, hopefully, if we didn't make too many mistakes. So the question is, will our code be satisfied here? So if we try to execute this, right? So first of all, let's just try to run it. There is no user interaction so far, right, of any sort. Oh, you know what? I way overdue to save this recording, hopefully.